Okay, children. Good morning, all of you. In previous class, we have discussed chemical combination and decomposition reactions. Chemical combination reactions, element plus element combination, compound plus compound combination, element plus compound combination reactions. Element plus element combination reactions are called synthesis reactions. Similarly, decomposition reactions. Element plus compound gives rise to element plus element. Compound gives rise to element plus compound. Compound gives rise to compound plus compound. Compound gives rise to element plus element decomposition reactions are called analysis reactions. For decomposition, energy is required based on the energy provided in the form of heat, in the form of electricity, and in the form of light. In the form of heat, thermal decomposition. In the form of electricity, electrochemical decomposition. In the form of light, that is photochemical decomposition. Okay. Here, thermal decomposition of oxides and hydroxides and carbonates and nitrates. Thermal decomposition. This is purely regarding thermal decomposition. Thermal decomposition of metal oxides. Now, these are all metal compounds. Metal oxides, metal hydroxides, metal carbonates, and metal nitrates. Here, if you observe the metal activity series, this is very important. Activity series. Here, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, here hydrogen, copper, mercury, silver, gold. This is metal activity series now. In this activity series, here up to aluminum, these are high reactive metals. Here up to lead, these are moderate reactive metals. Here from copper onwards, these are low reactive metals. This is the hydrogen, position of hydrogen. Above the hydrogen in the activity series, these metals are more reactive metals, more reactive than hydrogen. Here below the hydrogen, these are less reactive metals, low reactive metals. Okay, if you observe the oxides now, metal oxides. Here, from potassium to copper, from potassium to copper, means from K2O to copper oxide. These are stable oxides, thermally stable oxide. The meaning is, when we heat this from copper oxide, from potassium oxide to copper oxide, these oxides are stable. The meaning is, when we heat these do not decompose. Yeah. Okay. These are stable oxides, means these do not decompose. But in the case of copper oxide and mercuric oxide, here mercuric oxide and silver oxide. Look at this, HgO converted to Hg plus O2. Here silver oxide, Ag2O gives rise to Ag plus O2. These are low reactive metals. From sodium, from potassium to copper, these are stable oxides. Here these are thermally unstable oxides. When we heat these, they decompose to oxides, means metal plus oxygen. These are unstable, thermally unstable oxides. Similarly, hydroxides now. Hydroxides. In the case of hydroxides, look at these two oxides, sodium and potassium. Potassium hydroxide and sodium hydroxide. These two are stable hydroxides. Here, remaining hydroxides up to calcium, up to copper. These oxides are hydroxides are decomposed into, look at this here, zinc hydroxide decomposed to ZnO plus H2O. Here Cu, OH taken twice, CuO plus H2O. Means these are decomposed to metal oxide and water. Here thermally unstable. If you observe the mercuric hydroxide, here it is decomposed into, look at this, here metal plus oxygen plus water. Look at this, here three different types of decompositions. Very important. Here potassium and sodium hydroxides are stable to heat. These do not undergo decomposition. But here moderate reactive metals, in these cases they are decomposed into metal oxide and water. But low reactive metals like mercury, silver, they decompose into metal plus oxygen and water. This is about decomposition of hydroxides. Similarly, carbonates, decomposition of metal carbonates. Carbonates. In the case of carbonates, potassium carbonate and sodium carbonate, these two are stable. Again, what is the meaning stable means? These do not undergo decomposition. But in the case of remaining metals up to copper, they are decomposed into, look at this zinc carbonate. When we heat this, it produces ZnO, carbon dioxide, metal oxide plus carbon dioxide. CuCO3 gives rise to CuO plus CO2. Here this is a first type, this is a second type, and here third type. Look at these low reactive metals. Here HgCO3 gives rise to Hg plus O2 plus CO2. Here Ag2CO3 gives rise to Ag plus O2 plus CO2. These are the three different types of decomposition of carbonates of different metals. More reactive metals, high reactive metals are stable. Whether metal oxides, hydroxides, and carbonates are stable. In moderate reactive metals, they are decomposed into metal oxide and carbon dioxide. Here, low reactive metal carbonates are decomposed into metal plus oxygen plus carbon dioxide. Is it clear? Similarly, decomposition of nitrates, metal nitrates. First type, here potassium and sodium, here KNO3, decomposition, KNO2 plus O2, KNO2 plus O2. Here metal nitrate, this is metal nitrite, nitrate converted to nitrite. First type. Here high reactive metals, whether potassium, or sodium. Second type now. Here look at this moderate reactive metal here, lead nitrate. Lead nitrate. When we heat this, it produces metal oxide, oxygen plus nitrogen dioxide gas. This is a low reactive metal nitrate, moderate reactive. Here metal oxide, oxygen and nitrogen gas. Here in this decomposition reaction, we observe brown color fumes. Here this is a pure solid thermal decomposition. We already discussed by taking boiling test tube. Here adding of 2-3 grams of lead nitrate. By heating of this on Bunsen burner, we observe brown colored fumes. Those are obtained from the mouth of the test tube. NO2 gas, nitrogen dioxide gas, brown color fumes are observed. This is a thermal decomposition of nitrates of moderate reactive metals. Similarly, in the case of low reactive metals, here we observe here metal plus oxygen plus nitrogen dioxide. So three different types. Here high reactive metals, metal nitrates converted to nitrites. Moderate reactive metals, metal nitrates converted to metal oxide, oxygen and nitrogen dioxide. In the case of low reactive metal nitrates, metal plus oxygen plus nitrogen gas. These are the thermal decomposition of oxides, hydroxides, carbonates and nitrates. Is it clear? This is regarding decomposition reactions. Okay, remember this activity series, Nana. Not only these, we have a number of metals, but at this stage, this is very reasonable activity series, Nana. Here, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. Here, up to aluminum, high reactive metals, up to lead, moderate reactive metals. Here, below the hydrogen, those are low reactive metals. Okay. In types of chemical reactions, the third type is chemical displacement reactions. Chemical displacement. So far we have discussed combination, decomposition. Combination means A plus B gives rise to AB. Decomposition, AB gives rise to A plus B. This is displacement. Look at this, very easy to understand. Displacement, also known as substitution reactions. Look at this general representation of chemical displacement. AB plus C gives rise to AC plus B. Look at this. Here C displaces B position. So B was displaced by C. So AB plus C gives rise to AC plus B. These are called displacement reactions. In this displacement reaction, here we have three different types of displacement reactions. Here metal-metal displacement, here metal non-metal displacement, here non-metal displacement. In this activity series, this is called metal activity series now. Similarly, we have non-metal activity series, fluorine, chlorine, bromine and iodine. Here in this activity series, metal activity series, here high reactive, moderate reactive, low reactive means from top to bottom, metal reactivity decreases. Similarly, in non-metal activity series, here fluorine, chlorine, bromine, iodine, from top to bottom, non-metal reactivity also decreases. So fluorine is more reactive non-metal, iodine is least reactive non-metal. Here, sodium, potassium, calcium, magnesium, aluminum, these are more reactive metals. Here, copper, silver, gold, mercury, these are low reactive metals. So, activity top to bottom decreases. So, in this metal-metal displacement reaction, here, high reactive metal always displaces low reactive metal. That means, in activity series, the metal which is present above that, in the position above, that metal displaces bottom metal. Means top metal always displaces bottom metal. Here bottom metal does not displace top metal because bottom metals are low reactive metals. Only high reactive metals displaces low reactive metals. Low reactive metals do not displace high reactive metals. Similarly, non-metal activity series, high reactive non-metal displaces low reactive non-metal, but not low reactive metal displace high reactive non-metal. Your third category, look at this, metal non-metal displacement. Metal non-metal displacement reaction, here metals displaces hydrogen. Okay, these are the three types of chemical displacement reactions.